We had some minor issues when we cut the kit chassis down in the first place. We had some miscommunication, and we also missed a huge rule this year, and that's that your maximum robot volume includes your bumpers. Another key rule we want to point out is that your robot starting configuration must be within your frame perimeter, not the max volume. We're working on shortening our shooter intake because at first we had it at an angle, and now we want to make it straight up and down to save space. And when we made it straight up and down, it went outside of our max height.
Okay, so this initially starts 5 inches off the ground, so that when you drive up to a wiffle ball, this will be spinning, it'll spin under there, it'll get caught against the piece on the back, which will help it hold it as it gets lifted up, and it'll then fall over the top and into the hopper.
Our robot is primarily a park and shoot robot, so we will park at the key and make consistent shots. So right now the shooter isn't adjustable, but we would like to, if we have time, actuate the end of it so we can shoot from other places on the field.
Originally we were going to put a piece up here that goes all the way around, so the ball went through here and shot out that way. Yeah. But then we first did this in a test. This was just originally just a test fixture, but it's turning more into the final project because it works pretty well where the ball goes in here and the spin makes it go that way, and it goes perfectly pretty much into the hole now.
We also built this test stand for when we're testing it.
Which works actually pretty well.
We're working on mounting our gear box right now and should have it on the robot within the next couple of hours. We'd like to point out that there's room for improvement. We built it a little heavier and larger than we needed to. We're just trying to get the basic concept across.
And the gearbox. From there, it will go onto the lift. Then, the doors will open, freeing the cog. Our kicker will then kick the cog onto the lift. From there, the kicker will come back, the doors will close, and the robot will drive away.
We have a fully functional climber, but we see that it's much heavier and takes up more space than it needs to. We're working on a possible alternative that is lighter and smaller than the first. It's like the first drum, but instead of a guide into a keyway, we're using teeth like on a comb to guide the end of, like the knot on the end of our rope right into the drum. It works a lot better for gathering the rope, but we're worried that if the robot's weight isn't perfectly distributed, it would fall over and start wrapping around the drive shaft of the axle. We'd like to add walls to the end of the drum like a spool to keep it from tipping over.
So what we have here is a knot and a rope. This is actually called a monkey fist, so it's just a certain type of knot that we just stuck at the end. It's a really solid knot. You can use this for a lot of different types of climbing devices. So we have a really simple one. This is our prototype of a climber, which is just basically a steel tube with a notch cut of it where it twists and the ball catches into it and twists up. The driver's just going to come up, you're going to run into it a little bit, it's going to catch on the ball, and she climbs.
How far do we want to go?
And then we're going to design, in our next design, we're going to have barriers so it leaves it up. We're going to have really